You know, there's a secret language you're already fluent in, even if you don't realize it. It's the language of mathematical comparisons. It's the hidden logic you use when you're trying to find the best deal, or the fastest route, or even just deciding what to wear. So today, let's master the symbols that make it all happen.
Think about it. Every single time you ask yourself one of these questions, you're actually doing math. You're comparing one thing to another. Is this price less than that one? Is my drive time going to be greater than I thought? We're about to master the symbols that turn these everyday thoughts into clear, powerful statements.
So, here's the game plan for today. First, we're going to learn the basic language of comparison. Then we'll jump into some true or false to test our skills. After that, you'll be writing your own statements, finding the missing piece to a puzzle, and finally, we'll take it beyond the basics. Let's do this.
All right, let's dive right in. First up, the language of comparison. Look, there are really just 5 key symbols you need to know. Once you get these, they become the foundation for everything else. So, let's meet them.
This is the greater than symbol. The easiest way to remember this one is to think of it like an alligator's mouth, and it's always hungry for the bigger number. So, when you see 5 greater than 2, it just means the alligator wants to eat the 5, because 5 is greater than 2. Simple, right?
And here's its twin, the less than symbol. The logic is exactly the same. The alligator is still trying to eat the bigger number, but this time that number is on the right side. So a statement like 3 less than 9 just means 3 is smaller than 9. The open side of the symbol always faces the bigger value.
Okay, but what if you need to be super clear that 2 things are just not the same? At all. That's what this symbol is for. Not equal to. It's just an equal sign with a slash through it, making a really clear point. For example, we all know that 5 is not the same as 7. So we would write it just like this.
Now things get a little more interesting. This is the greater than or equal to symbol. It means the number on the left could be bigger, or it could be the exact same number. If either of those things is true, the whole statement is true. So 10 greater than or equal to 5 is true because 10 is bigger, and 5 greater than or equal to 5 is also true because they're equal. And to round out our toolkit, we have less than or equal to. It's the same idea. The number on the left is either smaller, or it could be exactly the same as the number on the right. So 3 less than or equal to 10 is true, and 10 less than or equal to 10 is also true. And just like that, you've got all the basic tools.
Okay, so we've met the whole crew of symbols. Now let's actually put them to work. I'm going to show you a few statements, and your job is to figure out if they're true or false. It's the best way to make sure this is all clicking. Ready?
Let's start with this one. Go on, take a quick second. See if you can solve this in your head. First, what's the deal with the left side of that symbol? Figure out what 20 divided by 5 is, and then compare it to 8. So, true or false?
Did you get it? The answer is true. 20 divided by 5 is 4. So the statement really just says 4 is less than 8. And yeah, that's definitely true. See? The key is always to simplify first before you compare. You're already getting the hang of this.
All right, ready for round 2? This one's a little bit trickier because you've got to do some work on both sides of the symbol before you can make a decision. So, what's 6 times 0 and what's 3 plus 5? Get those 2 numbers and then see if the statement makes any sense.
Let's walk through it. On the left side, 6 times 0, well, that's easy, it's 0. And on the right side, 3 plus 5 gives us 8. So the real question this statement is asking is 0 greater than or equal to 8? No way! So this one is false. This is so important. Always simplify both sides first. Then you can compare. Awesome job. Okay, let's switch gears a bit. Instead of just reading math, we're going to start writing it. This is a really cool skill, learning how to take a normal, everyday sentence and translate it into the super clear language of math.
So our goal here is to become translators. But we're not translating French to English. We're translating plain old words into powerful mathematical symbols.
Just look at how neatly these words translate into math. 25 is greater than 20 just becomes 25 greater than 20. Easy. For the more complicated ones, we use the same strategy as before. For 6 minus 3 is less than 5 plus 4, we first solve the parts. 6 minus 3 is 3, 5 plus 4 is 9, and is less than becomes our symbol. So 3 less than 9. It's a 2-step dance. Solve the numbers, then pick the right symbol.
All right, time to play detective. For this next part, we're not just checking if a statement is true. We have to make it true.
We're going to see an equation with a missing piece, and it's our job to find the one and only number that solves the mystery.
So here's the puzzle we need to crack. We have 29 minus something equals 4 times 1. The first rule of detective work here: simplify what you already know. The right side of that equal sign is a huge clue. What's 4 times 1? And the mystery number is, drumroll please, 25! Here's how we did it. The right side, 4 times 1, is just 4. So the puzzle really says 29 minus what number gives you 4? Well, 29 minus 25 is 4. Case closed.
You guys are crushing this with whole numbers. But I know what you might be thinking. What about those tricky decimals and fractions? Well, in our final challenge, we're going to see that even when the numbers look a little messier, the rules we've learned stay exactly the same. The process never changes.
Okay, I know this one looks a little scarier with those decimal points, but trust me, it's a paper tiger. The strategy is precisely what we've been doing all along. Solve the left side, then solve the right side, then, and only then, you compare the two numbers you got. You can totally do this.
So let's do the math. On the left, 4.6 minus 2.1 is 2.5. On the right, 1.5 plus 0.9 is 2.4. So that whole complicated thing really just boils down to one simple question. Is 2.5 greater than 2.4? You bet it is. So the statement is true.
So, what did we learn today? Let's do a super quick rundown. First, we know that symbols like greater than and less than are just tools for making precise comparisons. We've learned the golden rule. Always solve both sides first, then compare. We've seen that you can translate regular words directly into math. And finally, we know that all these rules work for any kind of number, whole numbers, decimals, you name it. And there you have it. You're now equipped with a seriously powerful toolkit for thinking logically. So here's my challenge to you. Sometime in the next 24 hours, try to find one decision you're making. Maybe it's about money or your time or what to eat, and frame it using greater than or less than. You might be surprised how much clearer the best choice becomes when you think like a mathematician.